Welcome to Physics of Life Thermodynamics. I'm glad you're here. Thermodynamics of Life is the subject of the first module in a series of 4. The other modules will consider biomechanics, fluids, and wave phenomena such as light and sound. Thermodynamics is the science of energy and work, and we're going to explore life as a thermodynamic phenomenon. Life is built by doing physical work on matter, and it's sustained by work being done to offset the ongoing degradation that all thermodynamic systems are susceptible to. We're going to approach our subject in 3 different ways. First, we're going to look at life as a sort of precarious disequilibrium. Life is highly ordered, and that means that it is out of equilibrium with its environment all the time. Energy needs to be expended to build this orderliness, and we're going to explore how. Life is a precarious orderliness because it's always degrading. We're going to define life in those terms, and we're going to work out basic concepts like metabolic rate. We're also going to see how the thermodynamics of life scales from the tiniest bacterium up to the biosphere. It will be a different way to think about life, I assure you. With that under our belts, we're going to explore the origin of life. We're going to see that our common scenarios for the origin of life, that is, as chemistry becoming biology, face some significant thermodynamic hurdles. We're going to explore what those hurdles are and show how an understanding of thermodynamic systems points us to a different and very fruitful perspective on how we think about the origin of life. Finally, we're going to look at how thermodynamic principles shape ecosystems, scaling up to a thermodynamics of the living system that is the Earth. We're going to use these thermodynamic principles to build a predictive model for how ecosystems should be structured, and use that predictive model to explore an interesting question about the biology of extinct ecosystems, namely, what kinds of animals were the dinosaurs of the Jurassic? So, without further ado, let's jump in.